Eyes. Stevie.
Yeast.
Becky. Jeremy.
Things that are less dense.
Things that are less dense. All right, now look. This balloon now, and we've got it tied down. We've got it tied down with rope because we don't want it to rise yet. Okay. Okay. We've taken this 10 pounds of air and we've heated it to expand it from 100 cubic feet to 200 cubic feet. If you take 10 pounds of anything and make it bigger, not heavier, but bigger, the density gets less dense. Now, if you expand it from 100 feet to 200 cubic feet, how's the density of the 200 cubic feet going to compare with the density of the 100 feet? Can anybody figure that out? Anybody figure out how the density will compare? When that air occupies 200 cubic feet compared with when it occupies, what do you think, Joy? How would the density compare, Joy?
Because the hot air expands.
Oh, yeah, but how would it compare? Give me a number. Who can give me a number of how it would compare? A number. Jackie?
Jessica.
Anybody give me a number? If 10 pounds of air goes from 100 cubic feet to 200 cubic feet, still weighing 10 pounds, what's going to happen to its density, Jessica? Is it going to get more dense or less dense when it's 200 cubic feet? Everybody ought to be able to. Who knows? Who knows whether it's going to get more or less dense? Jackie? It's going to get less dense. That's why a hot air balloon rises. It gets less dense. How much less dense? If it goes from 100 cubic feet to 200 cubic feet, how much less dense, Jeremy?
100?
No. Give me a fraction. How much less dense, Tanner? Jonathan?
50.
Huh?
50.
Well, you're on the right track, but you're not using exact math right. What do you think, Emily?
120.
Well, give me a fraction.
200.
The density of this is going to be what fraction of this? Do you know, Jeremy?
Yeah.
What?
1/2.
1/2. Look, 100 cubic feet of air is going to warm up and become 200 cubic feet of air. Still weighs 10 pounds, so its density is going to be 1/2. Well, okay. Look, the temperature out here is still 60 degrees. And here it's 75, and this is now hot air. What's air going to do if it's half the density of the outside air? What is it going to do? Give me one word that begins with R. Mason. It's going to rise. Right. Now, raise your hand if you've ever heard the phrase heat rises. Ever heard that phrase, the heat rises? All right, I bet if you go home and ask your parents tonight if heat rises, they'll say yes, but that's not a true statement. Heat does not rise. Here's the way you should word it, and I'm going to see after I tell you who can state it back to me. Hot substances rise in cold substances of the same type. Hot air rises in cold air. Hot water rises in cold water. Hot mercury rises in cold mercury. Hot alcohol rises in cold alcohol. It's got to be the same substance, though. Now, who's got a water bottle on their desk? A commercial water bottle. Tanner's got one. Okay, let me just use this a minute, Tanner. All right, a water bottle this size weighs 1 pound when it's full of water. If it's full of mercury, it weighs 8 pounds. Why? Why would it weigh 8 pounds if it was full of mercury? Can anybody give me a reason? Jackie or Jessica?
Because mercury is more dense.
How many times more dense, Jessica? 8 times more dense. Okay, look. There's no way you can make mercury hot enough to rise in cold water. Why? Why can't you possibly make mercury hot enough to rise in cold water? Emily?
Because it's not the same substance.
Well, yeah, because it's not the same substance and it's so much more dense. Suppose you made the mercury half as dense by heating it. Well, it'd still be 4 times more dense than water. There's no way you can make mercury less dense than water, regardless of how high you. That's why the saying has to say at the end of the same substance. All right, now, does heat rise?
No.
No. Who can give me the correct statement? State it back to me, Emily.
Heat rises only with the same substance.
That's not it. What is the correct statement, Tanner?
Hot substance rises with the cold substance.
Of the same type. Hot substances rise and cold substances at the same time. Okay, that's very important to know, but almost all of your parents have been told during their education that heat rises. But heat doesn't rise. It's hot substances rise and cold substances at the same time. Okay, so now I'm going to tell you something about a balloon. Okay, so they've got this balloon tethered, tied down with ropes. See, and they've got this gondola, this what you call a basket under here, like this, and then they've got this propane torch like this that can shoot a flame up here. All right, so it's all ready to go. It's half as dense as the outside air. Why is it half as dense as the outside air? Who can tell me why it's half as dense as the outside air? Why, Jeremy?
Because the outside air is cold and the inside air is hot.
This is hot air, and it's half as dense. Okay, so who can tell me? Who's somebody that hasn't participated yet today that can tell me where less dense things go? Where do less dense things go? Wyatt? Okay, so the balloon will go up if you release it. Now, suppose somebody gave you a hot air balloon ride for your birthday. Nice gift. They advertise these on TV, and they've got this glamorous balloon ride over the countryside. You're gently floating in the breezes. Beautiful scenery, not a sound. Okay? If they release these ropes, the balloon will go up. Now, it'll only go up so high, and then it won't go any higher. How does the pilot make it go higher? How does the pilot make it go higher, Chase?
Then he takes off the little weights.
No, that's the way it used to be before they had propane torches.
Oh, yes.
How does he make it go higher, Jonathan?
Expand the heat.
He turns the torch on. He turns the torch on. Okay, to make it go higher. Okay, now what some of you may not know is that the wind doesn't blow the same direction at all levels. Let's say you got a free ride for an hour. So the pilot wants to land in an hour when your ride's over. And he knows a nice landing spot, big grassy green field, an hour's drift away. So he goes until he gets a wind current that's going that direction, and then he tries to stay at that by turning the torch on and off. Okay, but there's one thing I forgot to tell you. You're given this balloon ride as a gift. The pilot's waiting for you to get in. He says, "Come on, get in my basket and we'll go for a ride." What's the first question you ask him before you get in the basket? Can anybody tell me what you want to be sure to ask him before you get in the basket? What do you want to ask him? What do you want to ask him, Chase?
Is it safe?
Well, that's related. That's related, Jackie. That's related, Mason.
How high are we going?
Well, maybe. What?
Are you getting cold?
Huh?
Are you gonna get the safe control?
Well, that's related to it. Look, here's what you ask him. You say, how many times have you piloted a balloon before? Why? Raise your hand if you know why you ask him that question. Why do you want to know how many times he piloted a balloon before, Allie?
Because if you just did it once, you don't know how.
If he says, this is my first time, I'm just learning, you don't get in the basket, okay? You want a pilot that's experienced, because even experienced pilots can probably land where they want to only 99% of the time. Not 100%, 99%. But an inexperienced pilot might only land where he wants to half the time. Raise your hand if when you go up in an aircraft, you want to know where you're going to land. You want to know that? I want to know that. All right. So you go up, you get over the field where he wants to land. Now this field is This field is surrounded by sticker bushes, barbed wire fences, power lines. There's a lake on one side, a river on the other side. You want to make sure you land in the field. How does he make it go down? Who can tell me how he makes it go down? How does he make it go down, Justin? Turns off the torch, all right? Now, there's a problem here. You'll never catch me in a hot air balloon, and this is why. I will not go in a hot air balloon. Okay. From the time he turns the torch off, it may take as many as 10 minutes for the balloon to start going down. It's not an immediate reaction. All right? What might happen in that 10 minutes that it takes it to start going down? What might happen, Janelle? You might pass the field and get over the sticker bushes or the power lines, okay? Now, I used to have a pilot's license, and I didn't mind flying in a plane, piloting a plane, because when I pushed the stick forward, the plane went down immediately. When I'm in an aircraft, I want to make sure it goes down when I say go down, not 10 minutes later. Okay, so you want to make sure the pilot lands, and because even the best pilots probably can only land 99% of the time rather than 100% of the time, I don't go up in a hot air balloon. All right, so that's the story of the balloon. Now, what's the basic reason why a hot air balloon rises? Somebody tell me the basic reason why a hot air balloon rises. Tanner.
Turns up the torch, the fire torch.
The air is heated and expands. And when it expands, it becomes less what? Dense. Okay. Now that's a balloon. Who can give me an example of something besides a balloon that you've ever observed to inflate or get harder? It was something filled with air besides a balloon that got harder or bigger when it got warm. Anybody give me an example besides a balloon? Besides a balloon. Jessica?
Like a bouncy ball.
Right. I have a sport court at my house with a basketball hoop, and I have grandsons and granddaughters that come over, and they want to shoot hoops, so I keep some basketballs out in a container outside where they can grab them and shoot hoops. Well, if they come over on a cold day, they say, "Gee, Grandpa, this ball doesn't bounce very well." If they come over on a hot day, they say, "Grandpa, this ball bounces really well." Why doesn't the ball bounce as well on a cold day? Who can explain that? Why doesn't the ball bounce as well on a cold day? Jackie?
It's better when the air's heated, like the hot air balloon needs air.
What happens to the ball on a hot day, Jackie?
It needs hot air to rise.
No, it's not because it rises better when it's hot. Why does the ball bounce better when it's hot? Stevie?
It's expanded.
It's expanded and the ball is harder. You should all know that a hard basketball bounces better than a soft basketball. Is there anybody that doesn't know that? All right, you all know that. All right, now, here's another example. Here's an automobile tire. All right, now, on the side of passenger automobiles, it says inflate them to 32 pounds pressure. Does anybody remember what the pressure is all around us here in pounds? Anybody remember that? You remember, Chase?
15 pounds?
Well, you're close, 14. 14, okay. If you've got 32 pounds of pressure in a tire, that means it pushes out in the tires relatively hard. Here's something you may not know, but it's important these days with the price of gas. You get better mileage out of tires if they're harder than if they're softer because there's less friction on the pavement. Okay, well, suppose you go out on a really cold day like this morning at my house. It was 26 degrees. Okay, the tires on your car look a little bit flat like that. Now, what some people do under that kind of a situation is they go to the nearest gas station and fill them up so they don't look flat, but you don't want to do that. Why? You don't, if they look that way when you go out to get in the car that's parked outside, you don't want to go in and put more air in. Does anybody know why? Why, Jeremy?
Because it might explode if it didn't use any air, it just got hot.
Well, you're on the right track. See, there's 32. What would happen to that air in the tire as you got the car moving? If the tires are moving on the pavement, there's friction. What's a four-letter word that describes what friction causes? What does friction cause, Tanner? Heat. What's going to happen to that 32 pounds when the heat affects it, Jake?
It's probably, the number's probably gonna go higher.
It'll go higher, and the tire might pop. Okay, here's a related application question. Raise your hand if you know what a blowout is. A blowout is when a tire does what? Pops. Okay. Raise your hand if you can figure out why there are more blowouts on warm days than on cold days. Why would there be more blowouts on warm days than on cold days, Joy?
Because on warm days, the tires expand.
The air is already expanded on a warm day. Then if you start moving and have friction of the tires against the pavement, it expands even more, and it could expand so much that the tire will pop, which is a blowout. Okay, now here's another example. I take my family camping up at Rife Lake every August, and one of our activities is to go sport tubing. We have a boat and a sport tube we pull behind the boat for people to ride on. Well, we want to make sure the sport tube is hard, inflated well, because a well-inflated sport tube glides over the waterbed. Okay, we pump it up so it's really nice and hard. We put it in the water so somebody can get in to take a ride. The sport tube always gets softer. Why does the sport tube get softer when we put it in the water? Who can explain that? Stevie? Anybody else over here? Anybody over here explain why the sport tube gets softer when we put it in the water? Why, Shayla?
Because the water's colder.
The water's cold, and what happens to the air in the sport tube when that cold water hits it? What happens to it, Justin? Well, it doesn't go out, it contracts. So it gets softer. Well, I don't know what to do about that. We just have to live with that and settle for the fact that the sport tube isn't quite. The way you deal with it is you make it so hard it's about to pop before you put it in the water, and then it won't deflate so much when you put it in the water. Okay, now, besides a sport tube, a basketball, a tire, and a balloon, can anybody think of anything else that you've seen that is filled with air that gets bigger or harder when it gets warmed up? There's something a lot of people have in their yards. Anybody have anything in their yard that's filled with air that gets bigger or harder when it gets warm? What, Stevie? What, Kendall?
Things like little kids go play.
Who has a little portable kid swim pool that's filled with air on the side? Have you ever noticed it's harder on a hot day than on a cold day? All right, who can explain why it's harder on a hot day than on a cold day? Who can explain that? Nobody can explain why it's harder on a